If you have your sample exams and you haven't handed them in, just kind of pass them up or put them in the stack or something like that. I would appreciate that. Okay. All right, well, today is second hour exam review. That means the second hour exam is coming up. By coming up, I mean it's Wednesday. So that's like the day after tomorrow. So please remember that. It's in the lab room, D204, 11 o'clock. Again, you may have your 3x5 card. I will give everyone a periodic table. Now, in this room, hidden back there somewhere, we have a little thing of calculators. In case you forget yours, I'm not sure they have them in 204. So please remember to bring your calculator. I will check to make sure, but I'm not sure. That's it. Remember, before we start the exam on Wednesday, the quiz must be completed. The departmental assessment must be completed. And it's at 11 o'clock exactly, all the tutorials disappear. So get everything done by 11 o'clock on Wednesday. Are there any questions? Yeah.
You said if we had over 350 in the classes, that was like pretty much an A, right?
Pretty much. But you must take exam 2. That's the rule. All right, let's go ahead and look at this thing. In which of the following are the name, formula, and solubility properly matched? Iron 3 chloride. Well, iron is obviously +3. Chloride, we remember, is -1. That is not. This is would be 6 positives, 3 negatives, doesn't work. And 3 chloride is FeCl3. Ammonium sulfate. That is ammonium, that's true. Sulfate is -2, ammonium is +1, so we do need 2 of them. However, this is hydrogen sulfate. Ammonium sulfate doesn't have a hydrogen. This is -2, each of those is +1. Calcium sulfate. Well, calcium is +2, sulfate is -2. Now we remember that most sulfates are soluble in water, except for barium, lead, and calcium. So this is not soluble in water. Aluminum chloride. Aluminum is a group 3 metal. It is a +3 charge. Chloride is -1. We need 1 aluminum, not 3. And finally, it must be E. We've worked our way down to that. Mercury 2 chloride. Mercury +2, 2 chlorines, that works. Insoluble in water. Well, most metal halides are soluble, except for the heavy metals, and that includes lead, mercury, silver, and copper. Any questions? All right, here we are reacting copper 2 sulfate and barium nitrate. We're going to get a precipitate. We want to know the chemical formula of the precipitate that forms. Well, this is a double replacement reaction. So our copper sulfate and barium nitrate are going to exchange ions. That is, the copper will pair with the nitrate, the barium will pair with the sulfate. As we saw on the previous slide, most sulfates are soluble except for barium, calcium, whatever. Our products, copper nitrate and barium sulfate. Simple double replacement. Any questions? All right, we get to balance an equation. Yes, you will get to balance an equation on the exam. So let's look at this guy. Start here with the ions and the oxygens. We have three oxygens on this side, only two on this side. This is odd, this is even. The first thing I would do is remedy the odd even thing here by putting a 2 in front of that to give us 6 oxygens on this side. Now when we do this, we're also doubling the amount of iron. We start off with 2. Over here we have 1. We need 4 irons. The oxygen, well, we put 6 on this side. We still only have 2 here. So we need to stick a 3 in to make that balance. And finally, the carbon. Well, we have 3 CO2s, that's 3 carbons. Simply need to put a 3 right there. And I think we're good. The balancing on the exam will be comparable difficulty. Any questions? Single replacement, we just did double, this is single. Remember, in a single replacement reaction, we're going to take an element and a compound, and we're going to form an element and a compound. So, here's our element, here's our compound. What's going to happen is we will react this, the element will pair with the anion and produce the metal here as the element. Single replacement, element and a compound, form an element and a compound. Copper is going to be our element, and iron to nitrate will be the compound. If you recall, we did this. We did it in lab. Remember, we took a dirty, ugly nail, wasn't shiny like this one, stuck it in copper nitrate solution, and the copper metal collected on the tip of the nail. Single replacement reaction. Everyone good? All right, which of these is not a redox reaction? Now, there are 2 ways to do this. The hard way and the easy way. The hard way. We're going to look at all of these guys and assign oxidation numbers. Okay. Nitrogen and hydrogen are elements. By definition, they're both 0. Here we have a hydrogen attached to a nonmetal. That will always be -1, or +1, I'm sorry. We have 3 positives here. That means this nitrogen must be -3. All right. Obviously, we have changed from 0 to -3, 0 to +1. Yes, this is a redox reaction. But if you think about it, if you look at your equation, and on either side of your equation, you have an element. That element is either going to start off as 0 or wind up as 0. So what's going to change? So if you have an element involved in your reaction, either in the reactants or the products, it must be redox. So, here we have aluminum as an element, aluminum in a compound, that's redox. We have oxygen in a compound, hydrogen and oxygen as elements, that's redox. We have oxygen in a compound, oxygen in an element. All of these guys are redox. Now this leaves only D as our option. Let's prove it to ourselves the long way. Oxygen, we said, will virtually always be -2. So let's let that be -2. That gives us 4 negatives. That means this nitrogen must be +4. Over here, oxygen is still going to be -2, isn't it? We have 8 negatives, 2 nitrogens, each one must be +4. Nitrogen has not changed from one side to the other, neither does oxygen. This is not a redox reaction. So the hard way, the easy way, and well, that's kind of the hard way too, I guess, but whatever. Any questions? All right. Another redox question. Here we have chlorine, and we're forming 2 chloride anions. This is a half reaction, so something else is going on too. But with regard to just the chlorine atom, is this oxidation, reduction, or not redox? Think of our definitions here. Oxidation is the loss of electrons. The loss of electrons. Reduction is the gain of electrons. The chlorine atom here has gained an electron to form chloride anion, therefore this is reduction. Oxidation is the loss of electrons. All right. You'll probably see something very similar to this on the exam, so make sure that you get it, okay? We have A and B and C reacting, and we're making D and E. We have a mixture with 2 moles of A, 3 moles of B, 6 moles of C. Which of these is correct? Okay. We have 2 moles of A. We need 2. We have 6 moles of C. We need 6. And we have 3 moles of B. We only need 2 of them, don't we? That means that B is in excess. So we have enough to do it exactly as written, don't we? And we'll have 1 mole of B left over. So 4 moles of D will be formed. Yeah, that sounds good to me. Only 2 moles of D will be formed. Nope. 3 moles of E will be formed. Yeah, that sounds pretty good. So we have A and we have C. Correct answer is both. Think about it. We have excess B. Aside from that, we have everything else we need to do this reaction. All right. Here we have calcium nitrate in solution. It's a 1 molar solution. We have 0.3 liters of it. We want to know how much calcium, how much nitrate, how much calcium nitrate, and whatever is in this little pot. What I want you to remember, here we have 1 calcium and 2 nitrates. If we took something like potassium sulfate, where we have 2-to-1 molar ratio, and we put it into 1, what happens is instantly this dissociates. We wind up with 2 moles of potassium and 1 mole of sulfate. This means we would have 1 mole of calcium, 2 moles of nitrate. That's what we're looking for. So, we have 0.3 moles of calcium nitrate. Well, concentration times volume gives us moles. Concentration times volume, 0.3 moles. Yep, that's right. 0.3 moles of calcium. Again, the mole ratio here is 1-to-1. I'm sorry, 1-to-2. Concentration times volume, 0.3 moles. We have 2 nitrates for every calcium. That's 0.6 moles of calcium, or nitrate. A, B, and C are all correct. Any questions? Well, let's do another stoichiometry question here. We are taking potassium chloride, reacting it with silver nitrate to make solid silver chloride and potassium nitrate. Okay? We have what? Half a mole of potassium chloride, half a mole of silver nitrate. Okay, look at the stoichiometry here. 1 mole, 1 mole, 1 mole, right? If we had 1 mole of each, we would get 1 mole of product, right? If we have half a mole of each, by George, we're going to get half a mole of product. So, the theoretical yield is half a mole. Yeah, that sounds good to me. 143 grams of silver chloride will be formed. Well, the molar mass of silver chloride is 143 per mole. But we're only going to get half a mole, aren't we? So we only get half of that. 1 mole of product will be formed. Well, gee, we just said we get half a mole, so that's not right. Potassium nitrate will precipitate? No way. Silver chloride precipitates, virtually all nitrates are soluble. So, A is the correct answer. Any questions? We're halfway done. These are all so simple, aren't they? All right, we do an experiment. We did this in lab. We take sodium hydrogen carbonate, heat it up. We get sodium carbonate, CO2 with water. Here is the balanced equation. What is the percent yield in this reaction? Okay. Let's see. We get 0.25 moles of CO2 from half a mole of sodium hydrogen carbonate. Well, as I look at the stoichiometry here, 2 moles of this gives 1 mole of that, right? So, if we had 2 moles of this, we would get 1 CO2. 1 mole would give us half. 0.5 moles would give us 0.25. We have 0.5, we get 0.25. By George, that's 100%. Worked nicely. Any questions? Simple dilution problem with a twist. Okay? We're looking for what volume of water we're going to add half a liter of 1 molar nitric acid to get 0.5 molar. And we have a choice. Well, we have half a liter of 1 molar. Concentration times volume gives us moles. We have half a mole. We want 0.5 molar. That's moles per liter, isn't it? Well, we have half a mole. We have 0.5 liters. How much more do we need? By George, just another half liter. That gives us 0.5 moles in 1 liter. Everyone get that? Simple molarity calculation. We have 0.375 moles. Our volume is 1340 mils. What is the concentration? We just said molarity is moles divided by liters, right? We have moles, we have milliliters. I have to divide this by 1,000. So 0.375 moles, 1.34 liters. What's the concentration? 0.28. Simple calculation. On the exam, if you have a problem like this, kind of show this as well. Makes for more integrity. And if you make a stupid mistake, I can still give you partial credit. pH, everybody's favorite. We have a solution with a pH of 5. We are increasing that to 7. What happens to the hydronium ion concentration? Does it increase by 2, 100, decrease by 2, or 100? Well, remember, if the pH is less than 7, it's an acidic solution. So we're starting with something that's acidic, and we're going to something that's neutral. So we're decreasing, aren't we? Look at these guys. We're doing 2 pH units. Remember, the pH scale is logarithmic. So this is 10 to the squared. 2 units, 10 to the squared. 2 pH units, factor of 100. We're going from acidic to neutral, so it's decreasing. Going 2 units, factor of 10 squared, or 100. Everyone good with this? All right, let's do a nuclear equation. We have selenium 80. We are losing an alpha particle. Okay? What do we make? Well, because it's an alpha particle, the mass number is going to decrease by 4. And the atomic number is going to decrease by 2. So we'll look at our periodic table. We are starting here with selenium. we are going to decrease by 2 atomic numbers. That's 1, that's 2, we're at germanium. So this is going to be germanium. 80 minus 4 is 76. Germanium, 76. Any questions? All right, this also has a little twist to it. It's dilution. We have 1 liter of half molar sodium hydroxide. That's a strong base, right? We have 1 liter of half molar HCl. That's a strong acid. If you add equal amounts of strong acid and strong base, they neutralize each other, don't they? So, the solution will be neutral. Yeah, that sounds good to me. Solution will be basic. Well, it can't be both. The concentration of sodium chloride will be 0.25 molar. The acid and the base are going to react to make a salt, right? What's the concentration of that salt? If we do concentration times volume, this is half a mole, but our final volume is the sum of these two. That's 2 liters. The volume is doubled, concentration drops by half. A little tricky. A and C are correct. Any questions? A little tricky. Have to remember you're doubling your volume, which cuts your concentration in half. All right, we have a solution where hydroxide is 10 to the minus 5 molar. What is hydronium? We can do that because we remember hydronium times hydroxide is always 10 to the minus 14. Okay? Always 10 to the minus 14. Here we know hydroxide. That means hydronium is simply going to be, well, here I just substituted. We're going to take 10 to the minus 14 divided by our hydroxide, and that will give us hydronium. We feed these numbers to our magic calculator, and the hydronium ion concentration is 10 to the minus 9 molar. Everyone happy with this? One more acid-base thing here. Which of these is acidic? All right, we have 2 scales that we could use, pH and pOH, right? If the pOH is less than 7, so let's pretend it's 5, pH plus pOH must always be 14, right? So if pOH was 5, pH would be 9, because they have to equal 14. pH 9 is basic, not acidic. Hydronium times hydroxide is less than or equal to 10 to the minus 14. We just showed this on the previous slide. This is nonsense. It's equal to 10 to the minus 14. Hydroxide is less than hydronium. Remember, in a neutral solution, they're equal, right? In an acidic solution, we have more hydronium. In a basic solution, we have more hydroxide. So if hydroxide is less, this is acidic. Everyone good? All right. Sadly, we did not get to do chapter 9 in class, but I hope everybody reviewed it, because there will be questions. You didn't, okay? There will be questions on the exam regarding chapter 9. So here we have a sealed cylinder, movable plunger. We adjust it so the pressure increases. The pressure increases. What happens to the volume? Well, intuitively, if you're going to squeeze it with more pressure, it's going to get smaller, isn't it? That's called Boyle's law. Pressure and volume are inversely related. Increase in pressure leads to what change in volume? It's a decrease. Squeeze it together. This is the temperature effects. We have our same cylinder, we're going to warm it. So the temperature increases. What happens to the volume? Well, this is called Charles's law. Charles tells us that temperature and volume are directly related. If you think about it, if you heat up something, it expands, doesn't it? You heat up the gas, it expands. Therefore, if the temperature goes up, the volume goes up. If you haven't reviewed chapter 9, please do. There will be probably 2 questions on the exam from chapter 9. And number 20 here. Oh, this is also from chapter 9. Remember, whenever you do a gas law problem, we must use the Kelvin scale. Kelvin scale is based on absolute zero, which is minus 273 centigrade. That means that centigrade plus 273 is Kelvin. Kelvin is always a bigger number, just remember that. So 273 is our magic number. We're at 100, add 273 to it, we're at 373. And our last one, the Socratic one. 3,3-diethyl-2-methyl-hexane. Draw the structure. On the exam, you will either draw a structure or do a name. Okay, so make sure you know both ways. First thing you want to do is look at this and say, how many carbons in the longest chain? It's a hexane. Hex means 6. So we start off with a zigzag with 6 carbons. 1, 2, 3, 4, 5, 6. All right. This is our longest chain, our parent. First thing we see, we have at carbon number 3, we have 2 ethyl groups. Ethyl is 2 carbons. Let's let this be carbon 1. We could let this be carbon 1, doesn't matter. That makes this 2 and that 3. So carbon 3, we have two carbon chains. We show those simply as going up and over, down and over. Doesn't matter how you draw the overs, because remember, they're changing constantly. All right, carbon 2, we have a methyl group. Methyl is one single carbon. So we show that just as a line going up, and that's it. This is 3,3-diethyl, 3,3-diethyl, 2-methyl hexane. Well, wasn't that fun? Exam is Wednesday. Bring your 3x5 card. I'll give you a periodic table. Bring a calculator because I'm not sure they have them. Everything must be done before 11 o'clock. And we're in 2:04. Here's our list of tutorials. There's lots. Do as many as you possibly can. All right, this has been a pleasure. See you on Wednesday. Oh,
sorry, I was reading it.
Sure.
And then, if I'm not.
You just have to let me know before the exam, please. Yeah. Just let me know as soon as you know. So try your best. That always makes it simpler, and then we'll work it out.
Do we still have class after the final exam?
After exam 2, people that are taking the final will have at least 2 more classes.
Can I see if I put my name on it? I don't know if I can.
Oh, sure.
Sorry.
Good.
Thank you.
All right.
You did?
Yeah.
Have a nice day, guys.
I will let you know by the end of today.
Okay.
Yes. And I was thinking if I could take it tomorrow, but
No, that doesn't work. I actually never give exams early. Don't like to give them late. If you can't make it, I can make an online version. So try your best.
yes.